In the first part of the question, we need to find the derivative of the parametric function we are given. So the formula for that is dy over dt over dx over dt. If you think about it, the dt's would cancel and then we will be left out with dy over dx, which is equal to m. So the derivative we want to find is the answer of this formula. So if you write it down, dy over dt would be derivative of 3t minus 1, which is 3, and the derivative of dx over dt would be the derivative of 2t, which is 2. So our first derivative of this parametric function is 3 over 2. Now if we want to find the second derivative of this function, then we need to write our formula as follows. Now if you think about this formula, the dt's would again cancel and we would be left out with d squared y over dx squared, which reads as the derivative of y with respect to x twice. So in order to find this, we need to evaluate this equation, and that would be equal to, the top would be equal to 0 and the bottom would be equal to again 2, which is equal to 0. So our first derivative is equal to 3 over 2 and our second derivative is equal to 0. For the second part of the question, our equations don't change, but we're just going to use theta instead of t. So our equation would be dy over d theta over dx over d theta. So now this is equal to this one's derivative, which is secant 2 secant squared theta over this one's derivative, which is secant theta tangent theta. So now these would cancel out, and if you do the trigonometry, it would be equal to 2 cosecant theta. This is our first derivative. Now in order to find the second derivative, we write the same equation with using theta this time. So now this one's derivative would be negative 2 cosecant theta cotangent theta over, as we found in the previous question, secant theta tangent theta. Now if you do the trigonometry, this would be equal to negative 2 cotangent cubed theta. And then all you need to do is to plug in the number that you're given, which is pi over 6. And if you do that, you will get a 4 for your first derivative, and you will get a negative 6 root 3 for your second derivative. In this question, in order to find the equation of the line tangent to the curve, first we need to determine the slope and we need to find the derivative for that. So again, our equation is dy over d theta over dx over d theta. This is equal to the derivative of this, which is 4 sine theta cosine theta over the derivative of this, which is negative 2 cosecant squared theta. Now if you do the trigonometry, this is equal to negative 2 sine cubed theta cosine theta, since this is 1 over sine squared theta. So then we need to use the initial condition that we are given in order to find what this value is. Now our initial condition was that the x coordinate, which is equal to 2 cotangent theta, is equals to 2 root 3. So cotangent theta is equal to root 3. These cancel out. So tangent theta is equal to 1 over root 3, which is equal to root 3 over 3. On the other hand, our y coordinate is equal to 1 over 2, as it's given, which is equal to 2 sine squared theta. So 1 over 4 is sine squared theta. So our sine theta is plus minus negative plus minus 1 over 2. So, if you look at these solutions, so this means that our theta is pi over 6, which would give us cosine theta equal to root 3 over 2. So let's just write that down in value. But we need to now determine the sign of this part of the question. So this is what we have in order to determine the sign of this portion of the equation. So we know that the tangent is positive, which means that the sine and the cosine have to have the same signs in order to make tangent positive. So sine and cosine are either both positive or either both negative. And if you apply these conditions into our equation, then that means this portion will always be positive. Now that we found the sign of that portion of the equation, we can just put in the variables we found into the equation. So negative 2 times 1 over 2 cubed, which is 1 over 8, times root 3 over 2. And if you do the math, this is equal to negative root 3 over 8. So this is equal to our slope. Now we need to find the constant in order to write our equation fully. And the formula for that was y minus its value over x minus the x value equals to slope. Now if you work this equation out, you would get the constant to be 5 over 4. So our equation would turn out to be y equals negative root 3 over 8x plus 5 over 4. This question is asking us the interval which the curve is concave up. In other words, the interval in which the second derivative is positive. So now what we need to do is to find the second derivative of this equation. Our second derivative, before finding the second derivative, since our equation was like this, we first need to find the first derivative. Now for that, we need to write the equation as follows. And then we need to find its value. So dy over dt is, in this case, e to the power of t. It's the same thing. And then x's derivative is 1 over t. So this is the first derivative. And then if we take the derivative of this is equal to e to the power t times t. So now if we want to find the value of this equation, we should take the derivative of this and put it into the denominator, which is e to the power t times 1 plus t times e to the power t over dx over dt, which is equal to 1 over t. So then, if we evaluate this, we would get t times e to the power t in parentheses 1 plus t. Now, we need to find in what interval will this equation be positive. E to the power of t will always be greater than or equal to 0. So we need to examine the other part of the equation, which is t times 1 plus t. So we want either this to be greater than positive or this to be greater than positive, or both to be smaller than 0. So if we want both of them to be positive, t should be greater than 0. And if we want both of them negative, then t should be smaller than negative 1. So our interval is either t is smaller than negative 1 or t is greater than 0. Outside that interval, this equation will always be positive, so the curve that we were given will always be concave up, since this is the second derivative. if we're looking for a horizontal or a vertical tangent, now if this is our equation, so if you're looking for a vertical tangent, the denominator should be equal to 0, but dy over dt should not be equal to 0. This would give us the vertical tangent. But if we want to find the horizontal tangent, which we are asked in this case, in this question, then the dy over dt should be equal to 0, but dx over dt should not be equal to 0. So what we're gonna find is when dy over dt is equal to 0 first. Now this happens when the derivative of this, which is 3t squared minus 3, is equal to 0. 3t squared is equal to 3, t squared is equal to 1, then t is equal to plus minus 1. So, we're not done yet. The trick in this question is to check if the denominator, if dx over dt is not equal to 0. Because if it is, then we have a L'Hopital situation and it's a whole different kind of question. Now, if we put these values into the derivative of x, which is -1 always, then we won't get something equal to 0. Then both of these values work. So when t is equal to plus minus 1, we have horizontal tangents on the curve.